Welcome to this lesson on momentum. Momentum is one of the fundamental concepts in physics that helps us understand how objects move and interact with each other. Today, we'll explore what momentum is, how to calculate it, and why it's so important in the world around us. So what exactly is momentum? Momentum is a measure of an object's quantity of motion. In simpler terms, it describes how much motion an object has based on two key factors, its mass and its velocity. The more massive an object is, or the faster it's moving, the more momentum it has. The formula for momentum is P equals mv here. P represents momentum, m represents mass, and v represents velocity. This simple equation tells us that momentum is the product of an object's mass and its velocity. By multiplying these two quantities together, we can calculate the total momentum of any moving object. Let's break down each part of the formula. P stands for momentum, which is measured in kilogram meters per second. M represents mass, measured in kilograms. And V represents velocity, measured in meters per second. Understanding these units is important because they help us calculate and compare momentum values correctly. An important characteristic of momentum is that it's a vector quantity. This means momentum has both magnitude and direction. The magnitude tells us how much momentum an object has, while the direction matches the direction of the object's velocity. So if a car is moving north at a certain speed, its momentum also points north. Let's work through an example. Imagine a car with a mass of 1,500 kilograms traveling at 20 meters per second. To find its momentum, we use the formula P equals mv. We multiply 1,500 kilograms by 20 meters per second, which gives us 30,000 kilogram meters per second. That's the car's momentum. Here's an important insight about momentum. A large mass moving at low velocity can have high momentum, like a slow-moving truck. Similarly, a small mass moving at high velocity can also have high momentum, like a fast-moving baseball. Both mass and velocity contribute equally to momentum, so either one can create significant momentum. One of the most powerful principles in physics is the conservation of momentum. In a closed system, where no external forces act on the objects, the total momentum remains constant. This means that the initial momentum before an interaction equals the final momentum after the interaction. This principle helps us analyze collisions and explosions. Momentum is crucial in many real-world applications. It's essential for understanding vehicle collisions and designing safety features like airbags. Athletes use momentum principles to improve their performance in sports. Rocket propulsion relies on momentum conservation to launch spacecraft. And physicists use momentum to analyze all types of collisions, from billiard balls to subatomic particles. Let's review the key points. Momentum, given by P equals mv, depends on both an object's mass and velocity. It's a vector quantity, which means it has both magnitude and direction. And in closed systems, total momentum is conserved, meaning it stays constant before and after interactions. Understanding momentum gives us powerful tools to analyze motion and predict how objects will behave when they interact.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.